Correlation and co-regression. First we'll do correlation. And then we will do regression. Types of correlation. There are basically two types: positive correlation and negative correlation. So in positive correlation, what do we have? We have suppose two variables x and y. If x is increasing, then y will also increase, and if x is decreasing, then y will also decrease. So in positive correlation what do we have? Both move in same direction. एक इंक्रीज हो रहा है तो दूसरा भी इंक्रीज होगा, एक डिक्रीज हो रहा है तो दूसरा भी डिक्रीज होगा. Okay, so that then x and y are called positively correlated. If x is increasing, variable x is increasing and variable y is decreasing, here they are moving in opposite direction. Suppose x is decreasing and y is increasing, here also they are moving in opposite direction. So we will say x and y are negatively correlated. If there is no correlation between x and y, means if x is increasing and it has increment of x has no impact on y, then we say x and y are not related. They do not have any correlation. So correlation that will be also called as zero correlation. And suppose x and y both are changing, but not because of each other, but because of some another factor z. Some another factor z, both x and y are increasing or decreasing, then we say x and y are there is spurious correlation between x and y. So when x and y are changing due to some another factor z, third factor, so we say there is spurious correlation between x and y. They change due to some another factor z. So these are basically the types of correlation: positive correlation, negative, and spurious correlation. Next we have measures of correlation. Measures of correlation. First one is scatter diagram. In scatter diagram, what do you have? The value of x and y are plotted on the graph. Okay, if you are getting the graph like this, they are moving in this direction. There are 6 types. First, yes, suppose you plot x and y on the graph, okay, and you are getting graph like this, means direction of the graph is from this lower left to upper right. Okay, this is in increasing order basically. So here we called it as x and y are positively correlated. There is positive correlation between x and y. Positive correlation means they both are moving in same direction. Okay, and here the value of r is called as correlation coefficient. It is greater than 0. r is greater than 0. Here it is a straight line. Okay, so in this we say x and y are perfectly positively correlated. Perfectly positively correlated. Next, when we have x and y and graph is downwards means this is upper left to lower right. When graph is from upper left to lower right, then value of r is less than 0 and we say x and y are negatively correlated. Negative correlation. This straight line from upper left to lower right, you call it as perfectly negative correlation. Here value of r is -1. And when you get graph like this where there is no specific pattern, okay, we say there is zero correlation between x and y, and this value of r is always lying between -1 to 1. First one is this, it always lies between -1 to 1. Second, correlation coefficient r does not have any unit, it is unit free. It is unit free. And third, r means correlation coefficient is not dependent on, it is not dependent on both change of scale and change of origin. It is not dependent on both of them. So this was about scatter diagram. There are 6 types. If graph is from lower left to upper right, it is positively correlated. If it is straight line from lower left to upper right, it is perfectly positively correlated. Same upper left to lower right, negative correlation. Upper left to lower right, if there is a straight line, it is perfectly negatively correlated. Then you have, in this you have to remember that in scatter diagram you cannot actually find the numerical value of r. You can just tell it will be less than 0, greater than 0, okay, or it is equals to 1 or equals to -1, but you cannot find exact numerical values. So this does not tell us exact numerical value, but it only shows the type of correlation we have, positive correlation or negative correlation from scatter diagram. Next one is Carl Pearson's correlation coefficient. Okay, so it is given by r is equals to covariance of xy upon standard deviation of x into standard deviation of y. This is the formula. Now, how to calculate covariance of xy? Covariance of xy is nothing but summation of xy upon n square minus mean of x into mean of y. This is covariance of xy. Formula for standard deviation of x, it is root of summation xi square upon n minus x bar the whole square. Similarly for sigma y will be summation of yi square upon n minus y bar the whole square. Sigma x, sigma y, standard deviation of x, standard deviation of y. So once we get the value of these three, we can substitute here and we'll get the value. As I said, r is between -1 to 1. Okay, and since sigma x and sigma y standard deviation are always positive, okay, so value of covariance of x, it can be 0, it can be positive, and it can be negative. So this was Karl-Pearson correlation coefficient, and we can calculate Karl-Pearson correlation coefficient when x and y are quantitative characteristics. दो टाइप्स होते हैं, एक क्वांटिटेटिव and other one is qualitative. So if x and y are quantitative, then we find Karl-Pearson's correlation coefficient, and the next one is rank correlation coefficient. Rank correlation coefficient. This is calculated, R we denote by R of R. This is calculated when x and y have qualitative characteristics. Now what is the formula for rank correlation coefficient? 1 minus 6 summation di square upon n into n square minus 1. How to calculate rank correlation coefficient? What we will do, suppose x and y is given, this is 16, 5, 4, 11. Suppose x is given, x and y is given like this. So what we will do, we will first rank them. You can rank them in ascending order or descending order. So rank this will rank by ascending order. 1, 2, 3, 4, 5 and 6. This is the rank of x. Similarly we'll rank y also. So this is 1, 2, 3, 4, 5, 6. In increasing order we have numbered them. Now what you will do, you will find the di, difference between the rank, this difference. Okay, so this is 302 plus minus 5 minus 1 minus 5. Now these are di. Now substitute the value here and we will get the value of rank correlation coefficient. Then we have coefficient, fourth one is coefficient of concurrent deviation. Coefficient of concurrent deviation. RC we denote, and the formula is plus or minus root of 2. Here also you have plus or minus. It is plus or minus 2c minus m upon m. Coefficient of concurrent deviation. It's very easy. How do we do? Suppose you have x as what? 21. What we will do? You just have to write, assign a sign to it in front of it, like for sign for this x. Here we'll do for x. So first one we will keep as it is. Okay, no sign here. We do not have any sign here. Now look at 9. Is it greater than 3? Yes. If the number is greater than the previous number, we will put positive sign, and if it is smaller, then we'll put negative sign. 8 is less than 9, so minus. 11 is greater, plus. This is also greater than 11, plus. this is less than 15, so minus sign. Similarly here we do not put any sign. Okay, now look, 9 is greater than 4, so plus sign. 3 is less than 9, so minus sign. 14 is greater than 3, plus. This will be plus, this is plus. Now we will look कहाँ पे we are getting same sign. Positive, positive, 1, 2, 3, 4. At 4 places we are getting same sign. So in this case C will be 4. In this formula C will be 4. And now what will be M? Total how many data we have? 1, 2, 3, 4, 5, 6. So we take one less than number of observation we have. So M will be 5. Now substitute this value over here. So what you will get? Plus or minus 2C. 2 into 4 minus 5 upon 5, which is plus or minus root of 8 minus 5 upon 5, which is 3 upon 5. Now inside the square root we are getting positive value plus 3 by 5. So outside the square root also we'll take positive value. If it is negative inside, then we'll take negative. Depending upon what if 2C minus M is greater than 0, we will take positive sign both inside the root and outside the root. If 2C minus M is less than 0, we will take minus side inside and outside both. So this is the method of concurrent deviation. So these were 4 measures of correlation. So it was about correlation, types of correlation, and then measures of correlation. Now we will do regression. Regression analysis. So in regression analysis, what do? We predict the value of one variable depending upon the other variable. Suppose y is equals to x plus 7, right? So this is the relation between x and y. Now we will, if x is 3, what will be y? Y will be 10. So basically what we are doing, we are predicting the value of y based on the value of x. So if there are two variables x and y, we will have two relations, two equations, okay, and that will be called as regression line. Regression lines. We have two regression line. First one is y on x and second one is x on y. These are two regression line. And how do we find these regression line graphically? By method of least squares. Least square method से दोनों correlation lines मिलते हैं graphically. Okay. And what is the point? See, suppose you have two graphs. This is if y on x, consider this line is y on x and this line is x on y. These two are regression line. Their point of intersection, this point of intersection will give you x bar comma y bar. Means you will get from point of intersection of two regression line, you get mean of x and y. Okay. First regression line is y on x. Okay. So what you will have on LHS, generally if it is y on x, you will have y here and here you will have a plus bx in this form. So this is y on x, and similarly the regression line x on y will be written as y is equals to c plus dy. Now this b is called as regression coefficient of y on x. On LHS, what do you have? Y, right? So y on x. Similarly, this d is called as regression coefficient of x on y. So b of xy. We denote regression equation by coefficient by bxy and byx. So we have two regression line, y on x and x on y. Similarly, we have two regression coefficient. They are bxy and byx. Okay, and if you take geometric mean of these two regression equation, geometric mean means bxy को byx से multiply करना है and then take square root. So this will give you correlation coefficient R. Correlation coefficient R. So regression coefficient are denoted by bxy and byx, whereas correlation coefficient are denoted by R. And what is relation between correlation coefficient and regression coefficient? They are geometric mean. Correlation coefficient is geometric mean of regression coefficient. This is how you do. R is geometric mean of byx into bxy. Now formula to find bxy and byx. There is formula. First, what you can do to find regression coefficient of y on x, what you can do, you suppose this is regression equation of y on x, and you want to find how to find byx. So what you will do, find the value of y from here. What will be y? So what you will do, simplify this. 2x plus 3y is equals to 6. So 3y will be 6. This will go here, minus 2x, and y will be 6 upon 3 minus 2 by 3 into x. Okay, so now the coefficient of x is minus 2 by 3. So byx will be minus 2 upon 3. This is how we can find regression coefficient from if equation is known. Okay, now another formula is b of xy. कैसे फाइंड करते हैं? r into sigma x upon sigma y. This is the formula, and here byx r into sigma y upon sigma x. See, first x then y, therefore x and y. Here what you have? Yx, so y upon x, y and then x. So this was about regression coefficient. And this is one formula. You can also write bxy and byx as covariance of xy. Here you have y, so write sigma square y. Similarly, byx can be written as covariance of xy upon sigma x square. This is correlation regression coefficient. Now we have properties of regression coefficient. Properties of regression coefficient. First property is given by I have already told you that correlation coefficient is geometric mean of regression coefficient byx into bxy. Second is regression coefficient. Coefficient is dependent only on change of scale. Correlation coefficient was neither dependent on change of scale nor on change of origin, but regression coefficient are dependent only on change of scale. Third, if the point of intersection of two regression line gives of two regression lines gives you mean x bar and y bar. Okay, these first and third are very important. Suppose two regression line are given, 2x plus 3y is equals to 5 and 6x plus 7y is equals to 13. Okay, these are two regression line and they will ask you to find mean. What is mean? So क्या करना है, ऑप्शन में से suppose 1,1 is given, 2,5 is given, 3,8 and 2,-1. Just put value of x and y यहाँ पे किसी भी इक्वेशन में देखो और कहाँ पे सेटिस्फाई कर रहा है. ओके, वंस इट सेट सपोज 1,1 पुट करो, सो 2 into 1 plus 3 into 1 which is 5, right? It means 1,1 are mean. x bar is 1, y bar is 1. ऑप्शन से जस्ट वैल्यू पुट करना है. once it satisfy the equation, then that will be your mean. We'll do next is coefficient of determination. Coefficient of determination you have. Coefficient of determination को कैसे डिनोट करते हैं, r square. Suppose r is 0.7 and they will ask you what is coefficient of determination. So it will be just r square, which is 0.7 square, which is 0.49. Now coefficient of non-determination. It is given by 1 minus r square. So 1 minus 0.49, which is 0.51. Okay, and we also write coefficient of this is how we calculate. Okay, and in theory coefficient of determination COD is given as explained variance upon total variance. This is coefficient of determination. Or coefficient of non-determination, is given by 1 minus this, 1 minus explained variation, or you can write variance upon total variance. Okay, so this was about correlation and regression.